Hello, and welcome to my talk on how to migrate data between services using Cloud Foundry tasks. In this talk, we'll show how to migrate the data between different data service versions by creating a fork of the service instance. This talk was born when our team was discussing how to support a path for migration between major versions and its difficulties. And even though we decided to go in another direction to solve this issue, we now see the value for the community in the approach presented here, especially because the proposed solution can even be executed by the application developer without the help of the platform operator. I hope that you all enjoy it. First, a little bit about me. My name is Heitor. I'm a Brazilian working for N9 for more than 4 years now as a platform engineer in the data services team, mainly working in automating data services using Bosch. That's enough about me. Let's go to the interesting part. In this talk, we'll understand the general migration concept and how to achieve it by forking a service instance. Then, we'll focus on the main core of the issue, which is executing the backup and restore, and what are the concerns and how Cloud Foundry can help us. Then, we'll go over a simple script with a case for PostgreSQL. After understanding what needs to be done, we'll show live how the procedure takes place. So first, let's dig a little bit into what does migration means in this context. In this talk, migration is the concept of moving data from one place to another. Specifically, moving the data from one service instance to another, where the original service instance is deleted at the end of the operation, leaving the data only at the destination. But why we need to migrate? There are many reasons for an application developer or a platform operator to migrate the data from one service instance to another. In our case, the path for migration between major versions was the main motivator, but anyone might be interested in just creating a service instance with a copy of the data of the original instance for any reason, maybe to test a new release of the application with real data, maybe to downgrade your service instance plane, or even to migrate across frameworks, a solution that in general is not supported. Let's understand quickly what we mean by forking a service instance. The basic idea is to create a live copy of data stored in a given service instance, where a fresh instance receives a copy of the content, creating a different, independent history of the data, in a scenario where both service instances can exist and changes in one does not affect the other. After forking the service instance, if we delete the original instance, we have effectively executed a migration in the strict sense of moving data from one place to another. So forking can be seen as a key step for migration. There are many approaches to fork a service instance. Restoring an existing backup into a fresh new instance is one way to accomplish this, or even creating a copy while creating a service instance. But of course, not all frameworks provide a solution, especially a solution that can be executed by the application developer. On the application developer side, and of course an operator can also execute it, it is possible to create a dump of the content that can be restored to a secondary service instance. We will see that there are some complications to accomplish this, but for the moment, let's check what are the necessary steps to fork a service instance. The very first thing we need to do is to create an environment where we can safely create a copy of the current state of the database. As some tools have some issues with concurrent write while creating a backup, we recommend considering pausing the writes while the process goes on. This way, we also avoid a possible split brain where the data written while the backup is taking place remains only on the original service instance. Note that this means a downtime window that needs to be discussed with the affected clients. And of course, if your intention is not to migrate but to create a live copy for testing, you don't need this step. Then we create a backup, a copy of the current state of the data, and we restore the scope of the data into a fresh new instance. Here, we delegate the handling of data format across versions with the underlying tools used to backup and restore. PostgreSQL, for example, using the latest version, you can create a dump from any previous version, so a path to migrate is always provided. After restoring the data, we need to make sure that the copy was successful and that data is correct. Of course, this is an action that is very dependent on data being transferred, so we will not get into many details at this point. After validating the data, you need to configure the service instance. Maybe you changed your mind and need a bigger service instance, or maybe you want a cluster solution. We recommend migrating always to a single noded plan to avoid the replication bottleneck and the effects that it can have on accumulated fragmented files. So this is something to keep in mind. And if you want to use a cluster, use this step to upgrade your service instance to a cluster or any other desired plan. With the service instance at the desired state, now it's time to bind the application to it. The clients can start using the new service instance at this point and forking is complete. At this point, it is expected that you have verified the data and that everything is correct, so if you wish so, you can delete the original service instance. We recommend leaving the service instance there for a period just to make sure everything is okay before deleting the original data. The most specific steps and the ones that require more attention at these points are backup and restore. We'll explore a little bit more these steps, what are the complications and how to get it done. Most of the data services provide the tools to create backup and to restore. The backup is created by dumping the content that can be streamed either by a file to a file or std out. PostgreSQL, for example, has pgdump to dump the content of a database and PSQL to restore the dump into a fresh database, so we can take advantage of that. In the same line, MongoDB has MongoDump and MongoRestore, and MySQL has MySQLDump and MySQL. Some other services use a different approach, like CockroachDB, for example, where you can store the backup directly on a blob store and restore from there, but the general idea still remains. These data services also offer other backup approaches, but there might be restriction like the need for administrative permission to handle configuration, which most of the time is not possible. So let's focus on the approaches that are generally available for the application developer. In this talk, we'll explore the general idea with a case for PostgreSQL, using the N9's PostgreSQL framework, but the idea can be applied to any framework. The backup approach and the tools to use are not the only concern, right? Considering what we have seen so far, our first instinct might be to create a dump file in our local machine and restore it into the destination service instance, but there are more things to keep in mind. As a good security practice, the data service might be accessible only from inside the Cloud Foundry app, for example. But even if you are in a machine where you can directly access the data service, you might want to consider that this traffic might go through the external network, which adds a cost, and depending on the number of service instances and the average database size might be relevant for the platform provider. Besides that, where will you store the necessary files? Do you have enough space? Are you legally allowed to store this data into the machine that you are planning to use? This might be tricky, especially because some companies and some countries have specific laws to protect data access. And here is where Cloud Foundry provides even more options to us. What we know is that the app can handle the access. And in this sense, we can access the environment to retrieve the credentials for the source service instance that is currently bound to the app. And if we bind the app to a secondary instance, the destination, then we can also access the destination instance. And if we can stream the data from the source to the destination inside this context, then the data don't need to leave the internal network, neither storing the dump in a temporary location will be a problem, since it will be contained inside the Cloud Foundry environment. There are some ways to access this environment, but we'll use Cloud Foundry app tasks in this example, which is perfect to execute a one-time task like migration. On Cloud Foundry, it's possible to execute a command in the context of the app via the cf run task command. This way, if we add a script to migrate to the app, we can execute this script under the same context of the app. But of course, the default stack does not provide pgdump and PSQL tools and other dependencies that we might need. To make these tools available for the migration test, we have a few options. We can create a build pack that provides the necessary tools, or use a containerized image if your Cloud Foundry environment permits, or we can include the dependencies in the app itself, which is the simplest solution and the one that we are going to use here. For this example, we have simply added a script to migrate and a lib directory with the dependencies to our example app. But you don't need to modify the original app in any sense. Any app with the content can be bound to the source and destination service instances and execute the migration. So let's take a look at our migration script now. For the PostgreSQL case, we need the pgdump tool and PSQL. We have also added JQ to handle the JSON format to extract the credentials from the VCAP services environment variable. And for PostgreSQL specifically, the stack does not have readline and zlib libraries. But as they are optional to provide history rollback for PSQL and compression for pgdump, we can compile without it. Let's talk about some details of this migration script. The Migrate script assumes that the source and the destination are bound to the migration app, and you will need to specify the service name of the source and the destination. In practice, what it does is to put dependencies in the path variable to make it easy to use. Then it loads the credentials from the vcap services variable for the source. Then it loads the credentials for the destination service instance. With the credentials at hand, it executes the data copy. The core part of the script is the pgdump and psql commands, where pgdump dumps the content directly to psql, which inserts it into the destination. You must read the documentation of these commands to use the parameters according to your scenario. In this example, we have used the minimum necessary parameters. So with all this in mind, let's go ahead and try out our approach. First, I want to show you, this is my original service instance. It is at Postgres 10, and this is my source service instance. And we have also created a Postgres 11 service instance, which is our destination. We can see that my app is bound to both service instances, and my app will be the app that will run the migration. My migrated app is just an app bound to my destination service instance, just to show that it's empty before we go ahead with migration. I would like also to show our manifest and highlight the services. So we are binding both service instances, our source and our destination, and we are also specifying by environment variables the name of the source service and the destination service. On my left here, I have the original database for my source service instance. We can see it has a table called posts, and that this table has 4 entries. On my right, I have my destination database, which at this point is empty. We can see, for example, my original app. Note that this is my app. And we have my migrated app here, which at this point is breaking because there is no posts table for it to read. Here on my left, I'll leave the migration task running, while on my right, I have the logs of the app, my app. So this way we can check the output of the migration task. While the migration task is executing, let me show you guys more or less the structure of the app. We have added the tasks directory, and inside this task directory, we have the MigrateDB task, with a very simple structure. We have a lib directory with the dependencies from JQ and the dependencies for PostgreSQL, and we also have the migrate script. The migrate script is very simple. Here we load the credentials from the source. Here we load the credentials for the destination, and as a last step, we execute the copy of the data using pgdump and psql, piping the changes directly without storing in the disk. So at this point, our migration task has finished. We can see the output of the psql command here. So far, no errors have been shown here. We can also see that the migration script finished with successful status, so everything looks good from the migration point of view. Let's check our first app is still running. Let's check our migrated app, which now shows the same content as our original app. Let's also check our database, where we can see that our destination now has the posts table, and we can also see that it also has the same 4 entries, so everything looks good. At this point, we could delete our original service instance or source service instance and unbind the my app. My migrated app can assume from there using the new Postgres 11 service instance. So that's it for our presentation. I hope you all enjoyed. For further questions, feel free to join me in the Q&A session after the presentation, or meet me at the N9's booth in this virtual summit. Don't forget to follow N9 in our social media channels, and once again, thank you for joining.